Hi everybody, this is Algebra 2, Lesson 33. In today's lesson we're going to be talking about the major rules of algebra and complex fractions. So there are a few rules of algebra that are important that we review and make sure that you understand. So rule number 1 is the same quantity can be added to both sides of an equation without changing the solution to the equation. And that we've been doing that since back in regular Algebra 1. That'd be like x plus 2 equals 6. We can go -2 on both sides. We did not change the value of the equation. These cancel. We get x equals 4. You guys know that. Super basic. The next one is every term on both sides of an equation can be multiplied or divided by the same quantity except 0 without changing the solution to the equation. So that's going to be like 3x equals 15. We can multiply or divide by the same quantity on both sides. So if we want to divide by 3 and divide by 3, we're going to get x equals 5. Okay? We did not change the value of the equation by doing that because we did it on both sides. These two rules cannot always be used for if we have either of these expressions. Okay, so if we got 4 over x plus y over x, we can't use that right here because these are fraction terms. We've got an addition problem right there, so we got to be careful with ones like that. All right, so the denominator-numerator rule is the denominator and the numerator of an expression can be multiplied or divided by the same quantity except 0 without changing the value of the expression. Only the form of the expression is changed. So that is saying, like, if we have 1/3, we can multiply that by 2 over 2, right? We multiply the top and the bottom. We can end up with 2 over 6, and that still means the same thing as 1/3. If we have 1/2, we can multiply that by 3 over 3, and we get 3/6. That still means the same thing as 1/2, okay? That's the numerator-denominator rule. So if we had 4 over x plus y, we can multiply the whole thing. And then we had plus x over 2, we can multiply the whole thing by, let's see, this one we can multiply it by 2, and 4 times 2 is 8, over 2 times x plus y. This one we would have to multiply times x plus y, and we would get x times x plus y over 2x plus y, and now we have like our denominators are the same, and we can add those. All right. When there is no equal sign present in this expression, we cannot eliminate the denominator, so we cannot get rid of the denominator. So if you have something like 3 over x plus 2 over y, we can't get rid of those denominators. We can make the denominators the same, so we can make them both be xy plus xy, right? This one we would say 3y, and this one we would say 2x, and we can add those together, and we can say our new bottom is xy, and we have 3y plus 2x. We cannot get rid of the denominator. So if we have an equal sign, then we can. So if we said 3 over x plus 2 over y equals 10, then we can say, okay, we're going to multiply this whole thing times x over y. Right? And we're going to multiply this times x over y. We're going to multiply this times x over y. If we multiply every single term in here, then we can get rid of these denominators. So these two cancel, and we would have 3y. And these cancel, and we would have 2x. And then that would be 10xy. See how we eliminated the denominator? We can only do that if there's an equal sign in there. You can't do it if you're just adding. It has to be a full equation before you can get rid of that denominator. You can change the denominator so that you have denominators that are the same so that you can add or subtract, but you cannot completely eliminate the denominator unless you're dealing with an equal sign. All right. Complex fractions. So fractions of fractions, such as the one just simplified, are called complex fractions. So let's say that we have the complex fraction of, this is 33.1, And we're going to work a complex fraction. So this is x over y plus 4 over yx over a over y. So what we're going to do is we're going to focus on solving this top part first before we try to get rid of this bottom. Okay, so what we want to do up here is we want to get a common denominator, and that's going to be xy. So our new problem, we have a division bar. We're going to have a over y on the bottom, but we're going to try to get a common denominator so that we can add these. So our new common denominator is going to be yx, and then over here we're going to have yx. This one we had to multiply times x to get that, and so we have to do the same thing on the top. X times x would be x squared right there, and then this one we didn't have to multiply it by anything, so we're still left with the floor, and that is going to equal x squared plus 4 over yx. Actually, I'm going to write it down here so we got more room. So we've got x squared plus 4 over yx, and this is still over our a over y. Okay, now that we only have one term up here, now we can get rid of this on the bottom. See, we couldn't get rid of it when we had two terms. We have to combine those, be able to add those first before we can get rid of this. So now we just flip this fraction, y over a and y over a, and these y's will cancel each other. All this cancels. Okay, and now we're going to have, my a looks like a 9, x squared plus 4. There was nothing we had to multiply it by because we canceled that y. Here we're left with an x and a y, an x and an a, and then that's the answer. Okay, so first we simplify the top, then we get rid of that bottom. Alright, let's try another one. 33.2. Okay, and I know these seem really long and kind of contrived, but alright, so a over x plus y, and we're adding that to m over y, and all of that is over x over a plus m. We're not even going to think about this bottom right now. We're just going to try to work the top. Okay, we simplify the top first, then we get rid of the bottom. Alright, so on this one, our new denominator, we cannot just say times, our new denominators are going to have to be y times x plus y. If this was xy multiplied, then we could just multiply it by x over here, but we can't do that because it's added. So there's a term, there's a term, and there's a term. We need all of those. So we're going to say y times x plus y for our first one, and then y times x plus y for our second one. Okay, and we've been doing problems that look like this, just not in this many steps. Alright, so for this one, I had to multiply times y on the top and the bottom. So my new top is going to be a y. Okay, and on this one, I had to multiply times x plus y to get that. Okay, so I'm going to do that on the top as well. Okay, so I'm going to get m times x plus y. Okay, now to simplify this even further, I'm going to multiply this out, and I'm going to get mx, and then I'm going to multiply it there, and I'm going to get my. Okay, so now I'm going to rewrite all that. So I would have a y, and remember, we still got to bring this over. Okay, so right here I'm going to have ay plus mx plus my, and that's over y times x plus y. Okay, so that's where I just added my factors right here. I just added those up. Alright, now I have all that over x over a plus m. So now what I'm going to have to do is flip this bottom one and multiply it times the top and the bottom to get rid of that. Whoops, that's a plus m. And then we do the same thing on the top, a plus m over x. Alright, can I cancel anything? Does not look like it. Alright, can't cancel anything, so I'm going to rewrite this. Alright, so I did not leave myself enough room here. I'll erase the top. If I could Alright, so first I'm going to have to write all of this as one top here. So I'm multiplying a plus m times ay plus mx plus my. Okay, so there's my new top. I just multiplied that times this big one. Okay, and my new bottom, see all these canceled, we don't have that anymore, is x times this term. So it would be xy times x plus y. And there's my answer. Alright, let's try another one like that. Well, there are no more. That was the last example. Alright, so do the practice, and then I will come back and work it for you. Okay, first practice, A. This has m over p plus 3 over zp. And all that is divided by s over p. Alright, so what we need to do is find a common denominator on the top, which is going to be zp. This one I didn't have to do anything to it. I'm going to leave it the same. This one I had to multiply times z, so I got to multiply the top times z. So that would be zm. Okay, now when I add these, I'm going to have zm plus 3 over zp. And all of that is over top of s over p. Okay, so now to get rid of that, all I have to do is flip this, p over s, and multiply it on both sides. This all cancels, and I'm just going to multiply p times that. So I would have p times zm plus 3 over, oh, I don't even have to do that. I can cancel. I didn't even see that. Cancel, cancel. There we go. So I have zm plus 3 over zs. So be careful with canceling there. Make sure you catch it if you can cancel. Alright, B is a little harder. It's not harder, it's just longer. Alright, so B is y over a plus m plus s over m. And that whole thing is over a over y plus s. Now when you're doing these problems, it's possible that you could just not even write this bottom part until you solve the first part. Get the answer to the first part and then put it over top of the bottom part. Alright, so first I have to find a common denominator, which is going to be m times a plus m. And over here I'm going to need the same thing. Okay, and then my new top, this one would be, this I had to multiply times m to get that, so times m up here, and so that's going to be my. And this one I had to multiply times a plus m, so a plus m up there, and so this one would be s times a plus m. And actually I am going to go ahead and rainbow that out, so it's going to be s times a plus m. And when I rainbow that, I'm going to get SA, and then I'm going to get SM. Okay, so then when I add these all up, I'm going to have m times a plus m, and then this will be my plus SA plus SM. It's basically we're just writing the same thing, just with only one. And remember, all of this has got that. Okay, so what I'm going to do is copy this down. So I'm just copying this same thing down over here so I have room. My plus SA plus SM. Actually, I'm going to do it way over here. That way we got plenty of room. So my plus SA plus SM. There's my whole top over m times a plus m. Then I've got all that over a over y plus s. Okay, now I'm going to flip this one. A. And then I'm going to do the same thing on the top. Okay, these cancel, so I don't have a bottom to worry about anymore. Notice I have to multiply over here, and it does not look like any of that is going to cancel. So I'm going to rewrite it with my y plus s in parentheses, and then this top, so m, y, s, a, s, m, all that in parentheses, and then my new bottom would be a, m, and that is the answer to that one. Alright, so that is it for lesson 33, and your homework for this week is 33. Alright, see you guys in class.